Okay, so this unit is all about transformations. We're going to talk about two different types of transformations today. We're going to talk about reflections and translations. Now, transformations we're going to talk about, reflections, translations, and rotations. We'll talk about these two today and rotations tomorrow. So let's start on reflections. A reflection is a transformation which flips a figure across a line or a point. Now, we're going to do 4 different types of reflections in this unit. So, our 4 types. And there's plenty of others, but we're only going to concentrate on these 4. We're going to do reflecting across the x-axis, reflecting across the y-axis, reflecting across the origin, so that's some point reflection that we just talked about, and then reflecting across the line y is equal to x. Okay, so we've got a couple of definitions we need to talk about before we get into some of these reflections. So the pre-image is the original figure before any transformations take place. Now, let's talk about the way it's denoted. Denoted means how it's notated. It's denoted with normal letters. So an example would be just triangle ABC. Has normal letters. Now the image is the figure after transformations have taken place. Now, let's talk about how this is noted. So it's denoted by using the same letters but they are primed. Now, primed meaning, just like our example before, we have triangle A prime, B prime, C prime. Those little symbols right here, that means prime. Now, an isometry is a transformation that preserves the shape and size of a figure. So it's a transformation that preserves the shape and the size of the figure. So the original figure and the new figure, so the pre-image and the image, are the exact same. So the shape of our figure has not changed, it's not gotten bigger, hasn't gotten smaller. And it has the same shape and size. Okay, so we're going to talk about those reflections. Now we got a little table here. It says reflected across, and we have the four things: x-axis, y-axis, origin, and y is equal to x line. So we have the pre-image, and this arrow means turns into the new image. So if you have an original x and y, if you are reflecting over the x-axis, what you do is you have x, comma, negative y. All you're doing here is you're changing the sign of the y. Now for the y-axis, when we reflect over that, we have negative x, comma, y. So all you're doing there is you're changing the sign of the x. Now when you're reflecting across the origin, we have negative x, negative y. We change the sign of both the x and the y to reflect over the origin. And then for the y is equal to x line, we flip the y and the x. So this table is something that you need to commit to your memory. Alright, so let's do example 1. It says rectangle LMNO, where L is at 0, 0, M is at 3, 0, N is at 3, negative 5, and O is at 0, negative 5, is reflected over y is equal to x. What are the vertices of the image? So the image is the final product. What happens to it after it's reflected? So we're going to take a look at the points, manipulate our points, and we're also going to graph it so we can kind of see what's going on. So when you're reflecting over y is equal to x, if you refer back to the chart, all we're doing here is we are flipping y, x. We're flipping these two. So L is at 0, 0. So when we reflect it, L prime is at 0, 0. Hasn't changed. M is at 0, 3. Oh, not 0, 3. Z3, 0. I'm jumping ahead here. So when you flip it, M prime is at 0, 3. N is located at 3, negative 5. So when you flip it, N prime is at negative 5, 3. O is at 0, negative 5. And O prime is negative 5, 0. So our final vertices are right here. Let's graph it and take a look at what happens. So I'm going to do the original one in orange. So we have 0, 0, 3, 0, 3, negative 5, and 0, negative 5. So here is our original. We're going to label our points as well. So we have L, M, N, and O. So when we reflect over the line y is equal to x, we'll move this so I can better see it. We have L prime is at 0, 0. Now this hasn't changed. That's L prime. Then we have M prime, which is at 0, 3. Then we have N prime, which is at negative 5, 3. Then we have O prime, which is at negative 5, 0. So here is an image of our reflected rectangle. And we can kind of tell because the line y is equal to x is right here. So that's our line that we're reflecting over. So let's move on to example 2. Example 2 says, given both the pre-image and the image of triangle ABC, determine which type of reflection has taken place. So this time we've given both sets of points, but we want to figure out what has actually taken place for us to get from the pre-image to the image. So if we take a look, first of all, we can go ahead and knock out y is equal to x line because they flip those. So if it was y is equal to x, we'd have negative 5, negative 2, which is not the case. Now, for the x-axis reflection, we change the sign of our y value. Now, our y value signs have not changed. For the y-axis reflection, the signs of the x's change. Now, it went from a negative 2 to a positive 2. So right now we're thinking maybe it's the y-axis reflection. Now, y-axis reflection, we change the sign of the x value. Let's look at B. The signs have changed. And for the y's, they're still the same. And look at C. First of all, we can't change the sign of 0, but our y's remain the same. So what we have here is we have a reflection over y-axis. Okay, now example 3 says triangle PQR, where P is at 5, 7, Q is at 0, 7, and R is at negative 3, 2, is reflected across the x-axis and then the origin. So we've got two reflections going on here. It says, what are the vertices of the image? So let's go ahead and let's write what it means to reflect across the x-axis. So we're doing the x-axis first. Now, you got to be careful because the order of these things does matter. You got to go in the order that the problem tells you to. So reflecting across the x-axis, we change the sign of the y. So we have x, comma, negative y. So let's go through our P, Q, and R, and let's change the sign of the y. So P is at 5, negative 7. Not negative, so 5, 7. There we go, jumping ahead again. So the new P is at 5, negative 7. Q is at 0, 7. So my new Q is at 0, negative 7. My R originally is at negative 3, 2. So my new R is at negative 3, negative 2. But we're not done here. After we do our x-axis reflection, we've got to do an origin reflection. So for the origin reflection, we take our point and we're changing it to negative x, negative y. So this time we're taking these points, we're starting with these, and we're going to change the sign of both of them. So P prime is at 5, negative 7. So we're going to double prime it because what we did was we did two different things to it. So we have a negative 5, positive 7. Q prime was at 0, negative 7. So our Q prime, we can't change the sign of 0, so we still have 0, but now we have positive 7. And R prime was at negative 3, negative 2. So R prime is at positive 3, positive 2 now. So here are our final vertices that we're looking for. So let's graph the original, and then let's graph our final. So our original one, we have 5, 7. So that is P. Q is at 0, 7. And R is at negative 3, 2. So let's draw our triangle. Okay, so let's do our final one, which I'm going to do in green. So we have negative 5, 7. That is P prime. We have 0, 7, which is Q prime. Then we have 3, 2, which is R prime. And let's connect. There we go. Now, let's talk about translations. Translations. A translation is a transformation that moves all points in a figure, or of a figure, the same distance and direction. So what we have here is we have a translation statement. So just like before, we have x comma y turns into, then we have x plus a, then y plus b. Now, the a represents the change in x. So this is going left or right. And if you're going left, we subtract. And if we go right, we add. Now the B represents the change in y. And this is going up or down. If you go up, you're going to add. And if you go down, you subtract. So let's do some practice writing translation statements. Example 4 says, write a translation statement that would move a figure down 7 units and right 2 units. So if we're going down 7 units, we're going to take our y and we're going to subtract 7 from it. So down and up is our y's. And if we're going to go right 2 units, we're going to take our x, and since we're going right, we're going to add the 2. So our translation statement is x comma y turns into, you have x plus 2, and then y minus 7. Okay, so example 5 says, translate triangle PQR 3 units left and 1 unit up. Given P is at 5, 7, Q is at -2, -3, and R is at 5, 0. So the first thing we want to do is write a translation statement. So if we're going 3 units left, now left and right is our X, so we're taking our X, and since we're going left, we're subtracting 3. And 1 unit up, that's for our Y's. Since we're going up, we're adding, and we're going up 1 unit. So I'm going to write my translation statement. XY turns into X plus minus 3, and then Y plus 1. Now we're going to do like we did before, except for this time we're going to add and subtract things to our P's and Q's and R's. So P is at 5, 7. So we're going to take 5, subtract 3 from it, and 7, and add 1 to it. And that's going to give us our P prime. So 5 minus 3 is 2. 7 plus 1 is 8. Okay, Q is at, originally, -2, -3. So we're going to take -2 and subtract 3 from it. And we're going to take -3 and add 1 to it. And that's going to give us our Q prime. So we have -5, -2. And then lastly we have R. And R is originally at 5, 0. So we're going to take 5, subtract 3 from it, and 0, and add 1 to it. So our R prime is at 2, 1. Now we're going to graph these as well. So let's graph our original. We have 5, 7. And that is P. We have Q, which is at -2, -3. So that's Q. And then R is at 5, 0. So let's connect these points. So there's our original triangle. Now let's graph our translated one. So this is after we've shifted it and moved it across our coordinate plane. So P prime is now at 2, 8. Oops. So that's P prime. Q prime is now at -5, -2. And R prime is now at 2, 1. And let's connect these points. Okay. And there, oh, I forgot my prime on my Q, is our pre-image and our image graphed. And here's our final vertices. Okay, so let's do the last example. So it says, example 6, translate triangle pig 3 units to the right and 2 units up. Then reflect over the y is equal to x line. Okay, so we've got 2 different transformations here. First, we've got to translate it, then we're going to reflect it. So make sure that you do them in this particular order. So let's talk about the translation statement we got to create. 3 units to the right, that means we're doing x, and we're adding 3 to it since we're going to the right. 2 units up, up is our y, and since we're going up, we're going to add 2 to it. So my translation statement is x, y, turns into x plus 3 and then y plus 2. So let's go ahead and translate pig. P originally is at -2, -8. So we're going to take -2, add 3 to it, -8, and add 2 to it. So P prime is at 1, -6. So now, let's take I. I originally is at -4, -5. So we're going to take -4, add 3 to it, -5, and add 2 to it. So we get I prime is at -1, -3. Now lastly, G originally is at 1, -3. So we're going to take 1, add 3 to it, -3, and add 2 to it. So we get that G prime is at 4, -1. Okay, so we've taken care of translating it. Now we've got to reflect it. Now, if you look back at your chart, to reflect this guy, we have XY, and we just flip our Y's and our X's. So don't forget, we're picking up where we left off. We're starting with these points this time. So P prime was at 1, -6. So our new P, so P prime prime, we have -6, 1. I prime was at -1, -3. So then when we reflect it, I prime prime is at -3, -1. And lastly, G prime is at 4, -1. So G prime prime is at -1, 4. So these are my final vertices for my image. So we're going to graph the original, and we're also going to graph our final image. So our original image, we have -2, -8. So that is P. We have -4, -5. So that's I. And then we have 1, -3, which is G. So let's connect these. And then for our final image, we have -6, 1. So that one is P prime prime. We have -3, -1, which is I prime prime. And then we have -1, 4, which is G prime prime. So let's connect these points.